AstroPosition, experimental, new in 13.2, unsupported in cloud. AstroPosition as alt defines the location on the celestial sphere with azimuth as and altitude out in the current horizontal frame at your geoposition. AstroPosition as r defines the location in celestial space with horizon coordinates as out in the distance r from your geoposition. AstroPosition coordinates frame use the given frame such as equatorial, horizon, galactic, etc. to define the orientation and meaning of the spherical coordinates chords. AstroPosition coordinates frame C system represents the location in celestial space given by a list of numerical coordinates chords reference to the given frame and using the coordinate system CS, IS such as Cartesian, cylindrical, etc. AstroPosition coordinates 1, coordinates 2 frame coordinate system represents an array of celestial locations. AstroPosition entity frame celestial system coordinate system returns the position of entity with respect to the given frame and coordinate system. Examples: specify location on the celestial sphere by providing its azimuth and altitude angles. AstroPosition azimuth 6 degrees, negative 10 degrees. Find the current position of the Large Magellanic Cloud with respect to your horizontal frame. AstroPosition Large Magellanic Cloud galaxy. Rotate these coordinates to the equatorial frame oriented along Earth's equatorial plane. Oops, okay, I need to evaluate this. I don't think I evaluated this one either. Draw a circle around that location. I have to evaluate this and this. Astrographics white circle percent astro range all astro reference frame equatorial astro background galactic sky. Current position of Mars in the International Celestial Reference System centered at the solar system Baryas Center in Cartesian coordinates. That didn't work for some reason. Let me try this. Entity, planet, Mars. Well, that doesn't work. Find the Earth-centered equatorial coordinates of Jupiter on a given date. Let me try reloading this. I don't know why this isn't working. Okay, let me do evaluation quit. This might fix it. Otherwise, I'll have to reboot Mathematica. Or it could be a bug with the documentation. There we go. Okay, AstroPosition Mars ICRS Cartesian. Extract the XYZ coordinate vector in astronomical units. Find the negative 0.1632111975 1.43040451 694 0.660490750509. Find the Earth-centered equatorial coordinates of Jupiter on a given date. AstroPosition Jupiter equatorial coordinate system. Date Wednesday 1 January 2020 12 00 GMT -5. I'm interested in the position of Saturn on the date. Let me do date. Date object from date string 2002 February 23:45:45 time zone Huntington, West Virginia. Okay, right ascension 4 hours 26 minutes. Declination 19 degrees 59 minutes. This is the distance between the centers of Jupiter and Earth at that instant in astronomical units. Distance. Plot the evolution of such a distance during the years 2015 to 2030. Again, astronomical units. So we can do plot astro distance Jupiter date object year calendar type Gregorian year from 2015 to 2030. What if I expand that to 2100? So it says downloading ephemeris for Jupiter and its moons 2050 to 2100. Elapsed time 10 seconds. Remaining time 52 seconds. Why is there a gap there? Scope, coordinates, angular coordinates are stored using degrees and distances are stored using astronomical units. So I can do AstroPosition. You do AstroPosition Sirius. (116 degrees, 30 minutes, 48.1 seconds, 5 degrees, 41 minutes, 47.5 seconds. Data. Specify an angular position on the celestial sphere in the CRIS frame, assuming the current date. AstroPosition. Quantity 6.5 hours of right ascension. Quantity negative 10.12 angular degrees. CIRCS. It's basically the same. Find the positions of a list of astro entities. Entity value. Entity planet. Entities. AstroPosition. 0 degrees 1 minute 17 seconds to 268 degrees 20 minutes 50 seconds. Altitude negative 89 49 minutes 15 seconds to 66 minutes. To 66 degrees 13 minutes 28 seconds. Provide coordinates using a quantity array object. So I can do quantity array random real negative 60 60 102 angular degrees. AstroPosition's equatorial. Negative 3 hours 58 minutes 49 seconds to 3 hours 53 minutes 36 seconds. Declination 59 degrees 16.2 minutes 2 seconds to 56 degrees 53 minutes 24 seconds. Astrographics, white point percent, Astro reference frame, ecliptic, Astro background, galactic sky, Astro range, all. So there's Regulus, Rolex, specify name directions in space, AstroPosition, true, equinox, true 70 degrees, 40 degrees, AstroPosition, true, equinox, TETE. Now it has a note on what this means at the beginning. AstroPosition represents observed astronomical positions on the celestial sphere in spacetime. It plays the role in astronomy that geoposition plays in geography. Celestial systems are always referred to a frame and oriented triple of orthogonal axes centered at a different location using a particular time system. AstroPosition chords is equivalent to AstroPosition chords horizon north as out. Possible inertial frames not rotating with respect to distant stars and centered at the solar system barycenter include ICRS or BCRS International Celestial Reference System, J2000 mean equatorial mean equinox of date J2000, B1950 mean equatorial mean equinox of date B1950, galactic inertial frame oriented with the plane of the Milky Way. Non-inertial frames centered at Earth center but not rotating with the Earth include GCRS, Geocentric Celestial Reference System, MEME, frame oriented along Earth's mean equator and using the mean equinox as x-axis, TETE, or equatorial frame oriented along Earth's true equator and using the true equator as x-axis, CIRS, Celestial Intermediate Coordinate System, Celestial Immediate Reference System, mean ecliptic, frame oriented along the ecliptic and using the mean equinox as x-axis, true ecliptic or ecliptic, frame oriented along the ecliptic and using the true equinox as x-axis. Non-inertial reference frames rotating with the Earth include TIRS, Terrestrial Intermediate Reference System, centered at Earth center and sharing the same polar axes as CIRS, ITRS, International Terrestrial Reference System, centered at Earth center and co-rotating with the ellipsoidal Earth horizon frame oriented along the local horizontal plane at a given geolocation and centered at the location. Also, parameters for a frame of the form frame parameter value param 2 value 2 include light time, whether to use geometric, retarded, or advanced coordinates, light deflection, whether to correct for deflection of light by massive bodies, gravitational time delay, whether to correct for Shapiro time delay, aberration, whether to correct for aberration due to observer motion, precession notation, model of precession and notation used, date or observation, date of observation, location, origin of the frame and location of observation, epoch and or frame definition, epoch, date defining the orientation of rotating frames, polar motion coordinates x prime, y prime of the ITRS, z-axis in the TIRS frame, refraction values of pressure, temperature, relative humidity, and wavelength for the computation of atmospheric refraction. Frame, date, location, loc, other parameters can also be given as frame, date, loc, other parameters. Given a frame, different coordinate systems can be used: spherical, cylindrical, Cartesian, or other projections of the spherical coordinates like Malweed, Mercator, and others. All spherical projections in the geo-projection data spherical are available. AstroPosition downloads ephemeris data files or solar system objects, storing them permanently in file name join user add-ons directory, application data Astro. So if I open that, I can see file name join user add-ons directory, or user add-ons directory. By user base directory. application data, Astro, and I can go all the way over here and I can do system open. Oh, didn't mean to go to the bottom. Where was I? Alright, so I can do AstroPosition, AstroPosition north, AstroPosition north, AstroPosition CIO, MEIE. Frames, AstroPosition but uses by default the horizontal frame whose XY plane is tangent to the Earth at your geolocation. AstroPosition Sirius star, AstroPosition Sirius, and it 118 degrees, 7 degrees. Use the galactic frame whose space axes are oriented along the galactic plane center that is centered at the solar system barycenter. AstroPosition. Here, let me do galactic 227 degrees 14 minutes, -8 degrees 53 minutes. Use the GCRS geocentric reference frame whose space axes are oriented along the ICRS end that is centered at the geocenter. AstroPosition Sirius, GCRS 6 hours 45 minutes, -16 degrees 43 minutes. Use the mean equatorial, mean equinox frame of a given epoch. AstroPosition Sirius, meme epoch now 6 hours 46 minutes 11.2 seconds, -16 minutes, and -16 degrees 45 minutes 22.7 seconds. Use the J2000 frame, the mean equatorial, mean equinox frame of date J2000, very close to the ICRS frame. AstroPosition Sirius J2000. Use the B1950 frame, the mean equatorial, mean equinox frame of date 1950, of date B950. AstroPosition Sirius B1950. Use the TET true equatorial, true equinox frames of a given epoch. AstroPosition Sirius TETE epoch now 6 hours 46 minutes 10.7 seconds, -16 degrees 44 minutes 55.3 seconds. Use the mean ecliptic frame of a given epoch. AstroPosition Sirius Sirius, mean ecliptic, epoch, now, I'm gonna take a break.